Hey math kids, today we're going to talk about the binomial distribution, and just heads up, this formula is kind of crazy. So we have probability and then x okay. So let's first talk about, there's a blue box on page 492 in your book. I'm just going to read it real quick. So in a binomial experiment, there are a fixed number of independent trials. There are only two possible results for each trial, success or failure. The probability of success is the same for each trial. Okay? All right, so if it meets all that criteria, then we can use this formula. And if we look into this formula, we're going to look right here. This is the number of ways x successes can be ordered amongst the n trials. Okay? And then this piece tells us the probability of obtaining x successes and n minus x failures in a particular order. Now, that may be kind of confusing. I think it's best just to jump into a problem and you can see how it's used. That's really the best way. So it's telling us to expand this. Okay, so if we expand this, we can plug it into this binomial theorem. And this example is a little strange because it kind of tells you the context after we expand it. So let's just expand it and then we'll talk about the context. So what we're going to do, so n is actually just this number. So we're going to say 5. And then I'm going to change this to a k. Okay, now our probability of a success is the first one. So that's what this p is. So 9/10. Our x is a k. 1 minus 9/10. And then our n was 5 minus x, which was k. Okay. Now this one could also have been written as 1/10 because this is the probability of success. Let's see. And then this is failure. Okay, so we have this, and what we're going to do is we are going to look at it going from k equals 0 to k equals 5. So if we plug in a 0 here, we can expand it. Now, we could go through this, keeping in mind that this is a combination, and this goes, like for this first one, when it's a 0, it's going to be 5, 0, which gives us 5 factorial over 0 factorial, 5 minus 0 factorial, which is going to be 5 factorial. 0 factorial is just 1, 5 minus 0 is 5, so we get 5 factorial. So overall, this is just 1 when we plug in a 0. Now, we could go through it that way. If we're just asked to expand, though, I think it's easier if we use Pascal's triangle. So I'm going to actually do it that way instead. But I'm just kind of showing you how the book wanted you to do it. Then I'm going to do it my own way. Okay, so I use Pascal's triangle, and I go to whatever this thing is, and I'm going to write it out spaced out. now I'm going to write out this starting at 5, 4, 3, 2, 1, and then not write it at all. And then do the same thing with 1/10, but go backwards. So 5, 4, 3, 2, 1. Don't write it. Put plus signs in between all of these. Okay, and then we just want to simplify that. So we plug it all into a calculator. I'm not going to take the time to do that. Actually, I think we can just leave it. Yeah, I just wanted us to expand it. Yeah, so we can just leave it right there. Okay, now part B says an archer has 90% chance of hitting a target with each arrow. If 5 arrows are fired, determine the chance of hitting the target. So that's what this represents, because it's 5. This is the probability of success plus the probability of not succeeding or failure, and then you had 5 trials. Okay. So we want to know the probability that 2 hit. So if we look at this probability distribution, this is when we get 5 hits. This one is 4 hits. And 1 miss. All right. Hold on. My pen's being weird. Okay. 1 miss. So this 3, this 2. So the yellow tells us that there's 3 hits, 1 miss. Once again, 2 hits, 3 misses, 1 hit, 2. Whoops, what am I doing? This one was 2 misses. This is 4 misses, and this is 0 hits, 5 misses. Okay. Now, if we want to put our x values, so this is x equals 5, x equals 4, it's just the number of hits. Okay. Now, it says we want to know the probability that he hits twice only. Okay, so basically, we're just going to take, let's see what color is going to work best for that. This. We're just going to take this piece, that's a 10, and then find out what it is, and that's going to give us that he hits it twice, like exactly 2 times. And so if we just plug that into a calculator, so first I'm going to do the 1/10 raised to the 3, and I'm going to times that by 9/10 squared, and I'm going to times that by 10. Okay, so there's 0.0081. And that is the probability that he will hit 2 targets. And then it says at most 3 times. So if we're saying that x needs to be less than or equal to 3, we're going to look at all of this. And we need to figure those out. Okay, so we already figured out this one. So I'm just going to figure out this one, and then we'll add them together. Okay, so I get 5 times 9 divided by 10. It's raised to the 1, so I don't need to do that. And then 1 divided by 10, and that's raised to the 4. Okay, so that's 4.5 times 10 to the negative 4. So 4.5. Okay, and so if we put a bunch of zeros over here, we got 1, 2, 3, 4, we get 0.00045. Okay, now we just need to do 1/10 to the 5th. And it's 1 times 10 to the negative 5. Which I should have known. But that's okay. Okay. 1, put a bunch of zeros. So we go 1, 2, 3, 4, 5. So we don't really need that one. Okay. Now we just need to add these 3 together. So 0.0081 plus 0.00045 plus 0.1234 1. And so we get 0.00856. And I think maybe I read it a little bit wrong. So it says at most 3 times. Oh, so we also have to include the 3. All right, let's do that too. So at most, so we're basically saying x is less than or equal to 3. So we need to figure this one out as well. Okay, go back to the calculator. So 10 times 9/10 raised to the 3. And then we're going to times that by 1/10 raised to the 2. 0.0729. Okay. Now if we add those 4 together, so I already have that on the screen, plus 0.00, or actually I can just add that, 856, because we already added those 3 together. And then it's 0.08146, 0.08146. And then if we round that to 3 significant figures, it's going to be 0.0815. If you need additional help, please come to Math Lab. Until then, calculator.